Fam, I know y'all been waiting for this.
Stop lying on me.
OAuth Part 2. We're jumping in. We're getting more advanced. We're going to learn about the different modes, and then we're going to think like a hacker. We're talking Recon, what to look out for, how to interpret the URLs that get sent back and forth, how to think creative, what happens after the Recon step, what do you write down, how do you start testing things, how do you actually start exploiting OAuth. We're doing it. We're doing it. I told y'all. I told y'all we're going there.
I told you. Why don't y'all believe me, man?
Really quickly, if you actually didn't watch OAuth Part 1, go ahead and watch that video. It don't have enough views, so watch that before you watch this one. And then like that video, and then comment, and then YouTube told me to say this stuff, man. And after you're done watching that video, come back, because we got something for you. We got something. All right. You know the history. You know plenty. You know, I don't even have to explain. Let's jump in, man. Let's jump in. All right. For all y'all who didn't want to watch video 1,
still,
a grant type or grant types are just methods in which the client receives an access token in order to grant it access to a resource based on the limited scope that you gave it. So grant types is just how the application will access a resource given the permissions that you instructed it to have or that you've set for it to have. That's pretty much it. Now, when we talk about grant types, there's about 7 that I want to go over. One in particular that's not, well, I mean, it is used, but you shouldn't be using it. But then there's some other interesting ones that I want to go over. So you'll know when we start going over OAuth, you'll understand what these grant types are and how they work. The first grant type I want to talk about is authorization code. This is where the application reaches out to the, well, usually it's like the authorization server, right? And the authorization server responds with an access code, and then the application will just use that access code to ultimately generate or receive an access token in order to have access to the resource that it needs access to. So generally, it is not recommended to send an access token directly from the authorization server back to the client because then that can get sniffed, and of course, like if that's taken, then you got other issues on your hands. But it is actually a good practice to send an access code back to the application and let the application use that code to request an access token, and then that token is then used to have, you know, to give access. That token also has like permissions set and everything as well. So that's pretty much the authorization code grant. The next grant that actually goes with the authorization code grant is the PKCE, the proof key for code exchange grant. It's so hard to say that sometimes.
Proof key for code exchange.
That grant. It's pretty much an extension. What that does is with the access token or the access code grant, you can probably imagine that attacks like cross-site request forgery, where a user pretty much just forges a request and then sends that forged request to the user and have the user log into the malicious application versus the legitimate application. That kind of attack still exists. So the PKCE is pretty much an extension of the authorization code grant that prevents the cross-site request forgery attack from happening. So that's the PKCE. It's not for authentication by itself. In fact, don't use that for authentication. You can't. Can you even? I don't think you can use it for authentication. Just know it works with the authorization code grant. PKCE. Can't forget. The next authorization code grant is the password code or the password grant, and it's a password. You use your password to log into the application, and the application responds saying, yep, that's your password. Nothing else to explain there. If you don't know what a password is, then I don't think you should be watching this video, but watch it anyway. The next grant type is client credentialed access. This is pretty much allowing a client to access a resource behind the resource server out of the context of the user. So the user has no involvement here. Pretty much the client will speak to the resource server and it will receive an access token based on the client. So it only has information to itself, whatever that client is, and that client will have access, would use that token to access the resources about itself. It's out of scope or out of, I guess, context of the user. There is no user information being sent there. So if you do see that, just know that you're not going to get any user related information with that. So if that's what you're looking for, keep it moving. But we're ethical here, so make sure you keep that in mind when you're doing this stuff. That's what the ethical fam is about, right? The next grant type is device code. This is pretty much for dumb clients, for lack of a better term. It's pretty much servers, or I guess clients that have low input available. And the way it works is instead of going through that whole login flow process, it actually just grabs a token that was previously generated and uses that token to access a resource behind a resource server. It doesn't really have the capabilities, we'll say, to go through that entire OAuth process. So it has to rely on existing tokens. That's pretty much a device code. Then you have your refresh tokens. Now, this is very useful, refresh tokens, but there is an inherent issue with refresh tokens. And I'm going to talk about that for, I don't know, maybe a minute. I don't know. We'll talk about that. So refresh tokens are pretty much there to allow access tokens to be generated without having to go through the entire authentication piece again. So once the application receives the access token, for example, that token, or we'll even say the client, that token, gets revoked after it expires. So after a certain amount of time passes, the token expires, or a user can manually revoke that token. Now, a refresh token is a token that allows you to generate a new access token without having to go through the entire login flow process. This pretty much allows developers to save on resources, right? You don't have to keep doing flows back and forth. You just have this refresh token that you can use to create an access token. And then once this refresh token expires, then you have to re-authenticate with OAuth. So it's more efficient. You use less resources. You can probably save on costs this way, but there is an inherent issue. You see, refresh tokens aren't revoked by default if an access token is revoked, which could lead to issues. Let me tell you a story. Let me give you an example. Billy, sorry if your name's Billy, you're in my example today. Billy, just worked at a company. He's really excited. He's really happy. And his account was authenticated with an OAuth protocol. And I don't know, we'll say OpenID, since that was kind of built on top of OAuth 2.0. And Billy has access to, the application XYZ. And Billy decides, I don't like this company anymore. I want to leave. He leaves the company. As, per usual, the company kicks off the termination process, which involves revoking Billy's access to the application XYZ. Now, Billy does not have an access code anymore, but Billy did save his refresh token. And the refresh token wasn't set to expire until later that night. So Billy goes in and uses his refresh token to generate a new access token, and then uses that access token to access the application XYZ, even though he doesn't work for the company anymore. And because the refresh token is not expired, Billy can access the application that the company owns and still do whatever it is he wants to do. Now, Billy's ethical. I hope. But as you can see, without other protections in place, there are things like, I don't know, there's a lot of things you could do, right? You can do like IP listing. You can allow, access to the application to be internal only. You could throw in certificate-based authentication on top of that. There's a lot of things you could do. Let's say this company decides to just rely on a refresh token with basic OAuth and some kind of third party to handle the identification kind of piece of it, things like that. Billy has access to the application now, and that's all because the refresh token didn't get revoked. So Billy wins. So refresh tokens are really useful, good to use at times, but just make sure that you have other things in place so that you don't get billied.
We don't want you to get billied.
Okay, the last grant type is implicit grant type. This is by far the worst. Actually, if you use this grant type, go on ahead and click off this video. This ain't for you, bro. The implicit grant type is pretty much just when the client reaches out to the authentication server and the authentication server sends a token directly back to the client. Now that client just uses the token to access resources that it needs access to. The reason why you don't want to send a token back is because of, a plethora of issues that arises. More notably, if an attacker is following that flow, or if an attacker is setting up an application, if the attacker is setting up a malicious application, well, he just got the token based on the implicit grant flow, right? The application sends a request and receives a token directly. So now that attacker has your token directly, he can just log in as you. When you use the access code, right, the authorization code, that code comes with more contextual based information. So when the client then uses that code to try to generate a token, there are more checks that can be put in place, like the PKCE and things like that. So an attacker can't just insert themselves and take your token. In fact, if they took your access code or your authorization, I don't know why I just stumbled on that. If your attacker took the authorization code, then they really can't use that code to generate a token unless they match the other contextual based fields that the attacker needs to match in order to request for the process to finish, to be successful. Do not use implicit grant. You don't want to send your access token directly back off of the initial authentication process. Okay, lot said there. We know grant types. We're experts in grant types, at least. Before we jump into anything else, I want to explain the difference between client ID tokens and something called access tokens. Right? So when you are looking at OAuth and you're looking at the OAuth path and all of the URLs that are involved, like the redirect URI, and then you have like the values there and things like that. When you're looking at that stuff, you will see something called like client ID, and then you'll see something called like access token. And a big difference between the two is that an access token is pretty much just meant to be read by an API. So that's about it. It receives the access token and performs functions. Pretty much it. Whereas the client ID has more contextual information about what happens when the user tried to log into the authentication server. So if the login was successful, the client ID would return and it would have that success plus more contextual information. And that's pretty much read by the OAuth client, which allows the process to continue. So access token is for API specific, not not much context outside of that. You get access to the API. That's it. That's all there is. Client ID, more contextual. Did you log in? Did the login succeed? Did it fail? Who are you? Who did you log in as? A lot more context there. So just keep that in mind. Recon. You got to do recon. It's boring. I know. I get it. But you got to do recon if you want to attack these OAuth services. You have to. So let's talk about it. So one of the things I recommend when going into OAuth, one of the first things is to try to identify the OAuth service in use. If it's an internal service, get lucky, I guess, because you're out of luck. I mean, if it's internal, you're just gonna have to get lucky. Hopefully it's somewhere in the host name, hopefully. But if it's external, which is what most OAuth services are like, external services, yes, look at the host name. Try to see if you can figure out what kind of OAuth service it is. It can say something like Google, for example, Google, Yahoo. I mean, there's a plethora of external services out there. Let's say it is Google, for example. Well, these services generally have public APIs for their OAuth service. If that's the case, look for documentation on that public API. It'll tell you what configurations are allowed, like grant types, things like that, like how state works, and just a bunch of things that can help when trying to map the specific attack patterns that might be applicable for this application. Once you identified the service, you probably want to get more information. So check and see if the configuration endpoint is reachable. If it is, you might be able to receive a JSON file that has configurations. There are two notable configuration endpoints. One of them is the OAuth authorization server endpoint. The URL to that, or the path to that, is you know what, I'll just throw it around. I don't know, wherever. I'll throw it up. The URL should be up here somewhere. The other is OpenID configuration, which is usually used for OAuth that has the OpenID component attached to it, and that URL is also going to be around the screen somewhere. Throw it up there, somebody. Okay, you know the type of service. You have more information on this JSON. What next? Well, now you need to know the grant types that are being used when you are initiating a login flow or the OAuth process. When you initiate the OAuth process, you look at the grant type, and that type will start to map the kinds of attacks that you're going to do. What I mean by that is if the grant type is like an implicit grant, well, now you know you're just going to receive an access token directly. You're not going to have to deal with access codes. So you can probably filter like some kind of CSRF based attack to grant the access token. And once you have the token, you don't actually have to, send the token back to receive like a code or a token. You have the token you need to interact with an API. If it's a different grant type, maybe it's like authorization codes. If it is authorization codes, then you probably need to use that code to get a token and then access the resource behind the resource server. So that grant type will be a little different, especially when crafting a cross-site request forgery attack. It's a little different. So make sure you know the grant type and you jot that down. And that's going to scope not only the type of attacks you're going to do, but how you're going to perform those attacks. While you're going through the OAuth flow, check and see if there's a parameter called state. If you do not see a state parameter, well, you have an attack there. If you do see a state parameter, see if it's the value for that state parameter is easily guessable, or you can probably figure it out with public documentation or so. Now, the state parameter pretty much allows the client and the service, the OAuth service, to maintain some kind of state when communicating back and forth. It means that the client is able to communicate with that OAuth service back and forth in this context, but someone can't just jump in the middle and start communicating back and forth with the OAuth service on behalf of the client, given that the state is there, the state parameter is there, and the value is given. That value is there to maintain the session or maintain the state of that communication. If it doesn't exist, an attacker can just initiate an OAuth process in the context of the user. If it does exist, but it's easily guessable, an attacker can include that in a request and pretty much just continue the OAuth process in the context of the user. So make sure that the state is there. If it's not there, jot that down in your recon steps. That is an attack path. If it is there, see if you can guess the value. If you can guess the value, that's a recon step. So make sure you jot that down. Next, you want to check the callback path. So in the OAuth process, there's a path called callback. That path is pretty much used to send the authorization code back. So the way it works, the client sends a request to the callback endpoint. That endpoint is what sends the response back with the authorization code that the client will then use to receive the authorization token. So if you see the /callback endpoint, check that endpoint. It's usually specified in a parameter called redirect_URI. And if that parameter's value, which has the callback URI in it, if that value is not validated, then you can specify the callback to be, let's say, a malicious URI. So let's go back to the cross-site request forgery. If that is set up to have the callback based on the redirect URI, right? The redirect URI being the victim's server, then the callback would send the authorization code to the victim server instead of the client. So you want to check those callback endpoints and make sure that the redirect URI is being validated. Lastly, something that I recommend is check and see if there's a proxy service in use. That's going to be very hard to figure out. Sometimes it's specified in like a header of a response, like a response header. Sometimes it's not in the response header, but you can probably try to do other methods to see if there's a proxy server in use. Now, I say this because even if OAuth is configured incorrectly, there might be a proxy server that's used to provide a sense of security. So a lot of these attacks like CSRF won't work because you're hitting a proxy service instead of the OAuth service directly. So the way that works is you hit the proxy server then forwards your connection to the OAuth service. Now, because of the nature of how proxy services work, you might be able to learn more about the internal environment based on this proxy service. So a proxy server usually whitelists URLs or allow lists for being, more modern with our terminology. And this allow list pretty much allows a proxy service to, forward traffic to specific domains based on the allow list that it is set to do. Now with this, proxy servers are vulnerable to attacks like directory traversal. So you might be able to not only look at different paths, but you might be able to, hit it with a .. and then a path like .. we'll say the boot.ini file for Windows, for example. If that's the case, you might be able to include that in one of the parameters for OAuth. And if you send that request over to the proxy service will take that parameter, forward it back to the internal environment. And then if directory traversal is, a thing or is done successfully, you'll receive the contents of the boot.ini file. So check for proxy services. If you do see a proxy server, then you might be able to go beyond the scope of OAuth and just, grab other directories using the OAuth process when we're talking to these proxy services. Okay, we know what to look out for. Let's jump into a few labs and see how that looks. Okay, so this is a lab that we're going to do just to show one of the vulnerabilities of OAuth. We'll do another lab depending on how long this video is, but let's dive into it. So with this lab, we're going to follow the same Recon steps as I mentioned before. So we always want to go to our account. It's OAuth authorization. So that has to be tied in with some kind of login flow. Okay, so there's the regular login to the app, and then there is the login with social media. So this login with social media is what uses the single sign-on, which is what is going to be the OAuth process. So we actually want to log in with social media, but what we want to do is intercept the request because we want to make sure that we capture first request that comes for the OAuth process to kick off. That request should have specific parameters and also shapes how we are going to approach the attack process. Okay, so let's intercept on. Let's log in with social media. Okay, boom. Really quick and easy. So we have our initiator. I call it the initiator. It's, OAuth it's the auth client, right? So it's in a client ID, then redirect URI, and then this is the redirect URI. In this case, it's redirecting to the OAuth login for the OAuth service. And then the response type is a code. So it's giving us an authorization code, which we know how that works. I don't need to repeat that. And then a scope. The scope is, it's using OpenID for the scope, and that is to view profile information and email. So this application will have access to my email and also profile. That's pretty much it. So going through the Recon steps, the OAuth service is not listed here. It would probably be listed later on. Oh, actually we see right here. Well, this is just the name of the OAuthServer.net. So this would be like the OAuth, kind of service here. Now we have that. We do have the response type being code. So although it doesn't tell us what the grant type is, we understand that the authorization code is the authorization code grant type. So we know that this is using the grant type authorization code. So whatever we do is usually going to be related to some kind of authorization code, and then using that code to get a token, or we can have our browser get the token for us. It all depends on how it works. One thing that we notice with our Recon steps is that starting off with the OAuth flow, there is no state parameter. So something like this and state equals. So there is no state parameter, which means that we can pretty much replay this authorization code without having to give the OAuth service any kind of like context. You know, we can use that code from any machine, meaning that we can probably do some kind of cross-site request forgery attack because all we need is the code and we could log in. We don't need any other context without the state and some kind of nonce. And there's neither of those here. So let's see here. Let's write that. So we'll say no state param, and then that's just possible CFRF. And we'll keep going. Let's forward. Let's turn in stuff off. It's supposed to redirect us to the sign in page here. Now let's sign in. Okay, we have the post request to sign in. We should receive an authorization code. Oh, now we have to actually authorize it, and then we should get the authorization code. There it is. So we have the OAuth login, and then we have the code here. So I'm actually going to copy this. Copy URL, and then we have that auth code because this is a auth grant flow. So we know we need the code, not the token. So I'm going to copy that just so you can see it here. Okay. Now that we copied that, let's forward just to make sure we can log in, and let's continue. All right. My account. Okay. So we're Peter Wiener, have an API key, and then we have a social media profile. So now I'm going to log out. And what I want to do is we know that it generates an authorization code. So I want to generate that code, but I don't want to use it to log in because we could use that code at a later time. And I'll show you what I mean. Once we use it, we can't really use that code anymore in this context. So let's intercept, let's log in with social media, forward this. And then once we get that code, so here it is, login code. So this is the code that I want. And I want to replace it here. I should have did this the first time. And then I want to drop that request. Boom. So now I drop it. I can turn this up off. Let's go back. And then this time, what I want to do is I want to log in into the blog like regular login. So we'll do Wiener. Okay, there it is. So you can actually, before I do that, I want to set up the cross-site request forgery on the exploit server, and then I'll explain what's actually happening. So what I want to do is, I didn't want to paste that. I want to paste, boom, I want to paste that. In this case, we'll use an iframe since it's pretty much embedded. So actually that should be that, and then the iframe, and then we need a source. So like that, and this should be like that, and we should have the closing iframe. This needs to be closed here. So boom, looks fine. And this is going to be in a file called exploit the cross-site request forgery. And the idea is that we actually send this to the user. So then we send this to the user, and the user clicks on it pretty much. So store, we send it. Okay, now let's deliver it to the victim. We want the victim to click on it. Boom. Okay, now the victim, us, we clicked on it, right? So we're going to log out account, and we're going to try to log in with social media, see what happens. Okay, let's try to do this. The authorization code didn't work on logging in with the social media. So we're going to try and see if we can exploit this a different way. So now what we want to do is try doing it from just attaching a social media profile. In this case, same thing. If we go forward, we get a ping. Okay, so we get another authorization code, and this is to attach a profile instead of actually logging in. So we're actually going to use this code, and we will erase that. Boom. We'll copy this, and then I want to drop this request because I don't want to attach it. I'll go back. Okay, now we're here. Now I can take this and let's see, replace it. Boom, store, and let's deliver that to ourselves afterwards. Once it actually, hopefully I stored it right. Okay, boom, boom. Okay, now I log in with social media, and I have access to the admin panel, which means that we successfully reused that authorization code, and a client, which is our browser, got the access token of the blog user, which is Wiener, and was able to attach my profile to Wiener, and then we were able to basically do an account takeover and log in. So you go to an admin panel, and I don't know, let's say you want to delete, where am I supposed to delete Carlos? Yeah, let's say you want to delete Carlos, and you just delete, and then boom, and you just kind of solve that. So the way this works is little interesting, right? So when you're, and we'll draw a circle. So this is your browser, right here. And when you log in with social media, just like the OAuth process, right? You go out to the authorization server. So say the authorization server, you log in, it sends back, it sends back context. And then after that, you get like an access code that you can forward over to the resource server. So let's say it sends back the code. So this is the access code. And then you use the access code to log into the resource server. I'm not going to continue the process, but this is the resource server. Boom. Okay, that's great. The OAuth process, of course, there's more steps. That's in part one. But in a nutshell, you send the request out, you get an access or you get an authorization code, and then you're able to access the resource. Now, what happens is the attack that we did is we use Recon to gain access to that access code. So this would only work if there's no state and we are able to actually get access to the access code. What happens is here, you know what? Let's just clear this whole thing. Okay. What happens is, yeah, this is your browser. Boom. That's your browser. B. You send a request to the authorization server. Boom. That request, the authorization server sends a request back that is basically intercepted by the attacker, because now the attacker can see that authorization code and then cancels the request. So like drops it. So the attacker inserts themselves pretty much in the middle here. Now the attacker has the authorization code, right? Or a valid authorization code at the moment. In this case, the user could generate a new request and just generate a new authorization code. That's fine. But this code hasn't been used yet. So the attacker can still use this code at any time. So what the attacker does is they set up a payload. We call that cross-site request forgery. And in this case, what we're trying to do is link our Twitter account. So the user wants to link his own Twitter account. So we'll say Twitter. And the attacker has their own Twitter account, for example. Boom. And so when a user sends a request to the authorization server to try to link their Twitter account, that request is intercepted, right? Or the access authorization code is intercepted. Now the attacker has access to an open authorization code. Now the attacker takes that request for that authorization code and sends that to the user as a URL, like, email style phishing, click on this and log in for support. If the user clicks on that, right? In this case, we'll say the user did click on that. What happens is the user actually links the attacker's social profile to the user's app, not the user's social profile. So now the attacker, all he needs to do is log into his to the application using his Twitter account, for example, and he has access to the user's account because that account is what's linked. So long flow, just know that the way this works is OAuth service sends authorization code, attacker intercepts that, links the attacker's account with the user's account pretty much. And it requires that the attacker sends the user a URL before linking that. So the user needs to be phished. And if he is successfully phished, well, you just got your account taken over. No password needed. So that's how this attack is working with OAuth. Okay, lots said there. Hopefully that all makes sense. Let's take a look at another kind of lab. Okay, this is another lab, and let's jump in. We're pretty much going to do the same thing. So first we want to go to my account, but I want to intercept the request first. So let's go to my account, and let's just go through and look at the OAuth process. We're looking for that initial OAuth flow. Boom. Okay, so that was actually relatively quick. So we got the initial OAuth flow. Let's go through our recon steps. We see that state, again, is not mentioned here. So state's not mentioned. That means we might have cross-site request forgery. So let's put that into our notes. No state, and we have CSRF. All right, and now what we're going to do is continue looking because we want to try to chain our vulnerability. And there are many ways to do that, right? So we can start messing with parameters. Client ID, I think I'm going to keep the same because I don't understand this yet. In the real world, we would look at documentation and see if you could change that. Redirect URI, this is something we're going to try to mess with, see if we can open redirect. If that doesn't work, we still have response type. That's set to code. We can set that to token and see if we can just get a token. If that doesn't work, we can always mess with the scope and see if we can change the scope to be like password or admin or whatever is, allowed for scopes. So let's start with the redirect URI. In this case, I'm actually going to go to the exploit server and have the redirect URI to be the path of the exploit server and see what happens. So let's see, change that and we'll forward the request. And then I'm going to, okay, now it's having me sign in. All right, exploit server is loaded, so that's good. So have me sign in. Let's see, go to sign in here. And the password is Peter. Okay, now let's intercept and sign in. Forward, ping, get an auth, ping, authorize that. We might have to log out and log back in so that because the browser now stores a token, so it'll just forward the request after that. Okay, so it looks like after it gives us a code, this would be the access token in this case. Okay, so it looks like it did redirect us to the exploit server. So that redirect did work. I don't really need this thing here. So it looks like there is open redirect, which by itself isn't going to be much, but since we're using cross-site request forgery, we are going to do a little more with that. So let's do this. Actually, let's take a look at the access logs. I don't need that right now. Test. I guess we need something. Okay, access logs. We have code right here. So this is what I was hoping to see. So it did send the code that we can probably utilize. So that tells us that open redirect can be used. In this case, we would have the account for Wiener, but I don't think this guy's an admin. So let's back up and just go to my account. Continue my account. Yeah, so Wiener's not an admin right now. So what we'd have to do with open redirect is, again, cross-site request forgery, where we send a URL to the admin. And if the admin clicks on the URL, we basically want to emulate this flow where it drops its code into our OAuth server. So I'll explain the steps while we're going through this one so you can understand. So first we want to do is log out, because we need some context here. So let's go to my account, and we're working on building our cross-site request forgery. So let's see. What we need is this right here. This entire, you know what? Let's just copy the entire URL. All right. So this is where we're going to do the open redirect, and we're going to create our URL. Now this is, we're just going to send this in an email to the admin, right? You want him to click on it. So what we want to do is, this looks fine. Auth client ID looks fine. Redirect URI, we definitely want to change that to our server. So we can turn intercept off here. So we want to redirect that to our server, which would be this. So here, redirect URI. Here it is. We want to redirect this to our server. Boom, just like that. Now, really quickly before I do that, this callback URL, that's the URL that's going to authenticate us. So that's the endpoint callback. So we want to send the code to that endpoint. So what happens is we want the admin to send his code to us. And then when we receive that, so when the admin clicks on a link, he sends a code to us. When we receive that, we actually will go to the callback. Boom. And that looks about right. So we would basically have this as a cross-site request forgery, like our own web server kind of thing. In this case, this is what we're going to use for this. We're just going to use the basic iframe because, Portswigger likes to have it set up like this. All right, boom. That's how we're going to have it. And then we want to close that iframe. So now it's an iframe. So now we want to store it, and we have our callback, and I think it was like code equals, and that was how the callback was set up. Okay, now we're sending the email to the victim, and the victim, we're hoping that he clicks on the link. And if the victim clicks on a link, we should get his token. So first, let's view the exploit. Okay, nice little iframe, and it sends invalid request. So unfortunately, I think I actually broke the lab. But the idea is that once the victim clicked on the cross-site request forgery link, that victim's token would go to the exploit server, which is my server. I have that token. I plug it into the callback URL, and then I get redirected because the redirect URI is part of that callback process. I get redirected to the application as the victim that clicked on a link, which in this case would have been the admin. And then I can just log in as the admin and do some things. That was it. It was just one step left. That should have happened, but looks like I broke the lab by having multiple sessions logged in, and in order to reset that, I need to clear out a lot of that cache and things like that. And we're not going to go through all that. That's a burden I don't want to go through. Wow, you're still here. Hope you learned something. I actually was going to go into a real life scenario and start doing things from Recon all the way through like assessing the security of things, but that's probably going to take another hour, and I don't think you want to be here for 2 hours, right? So fortunately for you, that means part 3 is coming. Stay tuned. Part 3 is going to be a live kind of bug hunt kind of thing specifically on OAuth, and to look for some of these things. So hopefully it'll be helpful for you. I know it'll be fun for me to do, so why not? But be patient. It'll come. If you like this video, subscribe, like, comment. We're only going to get better. I enjoy the feedback that I get from all of you guys. In fact, it helps me to improve a lot of the things that I do. And we only go into the top. That's it. That's what we're here for. That's what we're going to do. We're going to get to the top. All right, stay tuned. Make sure you go out there, you're testing those OAuth endpoints, and you're looking for those unique bugs and things like that. And if you're on the developer side, make sure that you're securing these OAuth-based services. They're third party. It's hard to secure, but we could try. Hey, appreciate you guys. Pap out.